Section 1.5 is about uncertainty and significant figures. This is an extremely mundane topic, and I'm not going to make a big deal about significant figures in this class, but we should be reasonable about them. Every measurement has some uncertainty. Professionals specify the uncertainty in their measurements by using plus or minus. And if they didn't specify the uncertainties in their measurements, then their measurements would never be accepted. So we will not use plus or minus because that's a cumbersome extra thing to drag around, and after all, we're just starting out here. So we'll use a simple scheme for roughly specifying uncertainty or precision of values. We will roughly specify precision of values by rounding off our values. For example, if I made a measurement of the length of the desk using an ordinary ruler, I might record the answer as something like 2.32 meters. But if I used a fancy measuring device, I might report the result as 2.3239 meters, suggesting that I have made a more precise measurement. I wouldn't bother writing down digits that I have no idea of their values. So that's kind of the idea of our scheme in this class. So a value like 2.32 meters has three significant figures, or sig figs for short. The 2 and the 3 and the 2 are each significant figures. 232 meters also has three sig figs. 0.000232 meters has three sig figs, because these zeros out at the beginning don't increase the precision of the value. They're just kind of placeholders that specify the place values of the 2 and the 3 and the 2. So this quantity is equal to 232 micrometers, which is clearly three sig figs. And the message here is that leading zeros don't count as sig figs. Zeros out in the beginning don't count. 232,000 meters. How many sig figs does that have? It's not clear. We might write that if we only measured to the nearest 1,000 meters, or we might write that if we measured down to the exact meter. So it's ambiguous. The authors in the textbook say it's ambiguous, but they don't have a resolution for that problem. We need to know a convention. I'm telling you that in this class, the convention is that number has 6 sig figs. Trailing zeros count. If you are trying to specify 232,000 meters with fewer than 6 sig figs, you should try something like this: 2.32 times 10 to the 5 meters. That has 3 sig figs. Or use a different unit, 232 kilometers. That has 3 sig figs. And they are equivalent to 232,000 meters. So let me ask you a question. How many sig figs is there in 0.006. The answer is 1. Okay, we know how to determine the number of sig figs in a value. What are we going to do with that? We're going to do calculations that have input values, and at the end we're going to get an answer, and we need to round off our answers to represent a reasonable amount of precision according to the input values. But don't round off intermediate results. Sometimes when you're doing a calculation that has multiple steps, you do some calculation and you get an answer and you use that to go on to the next part of the calculation, or maybe there's parts A, B, C, D in the problem. When it's time to report an answer to a problem, round it off. But along the way, you should use unrounded values. So if you're doing multiplication or division, the right way to determine the number of sig figs that your answer should have is the number of sig figs should equal the smallest number of sig figs among the input values. So if one of your input values has low precision, it's going to spoil the precision of the answer no matter how good the other inputs are. Let me show you an example. 7.20377 times 1.1 times 10 to the 4 divided by 1500 equals, well, if I get out my calculator and run these numbers, I get 52.8276, but that's not the answer. I should put a box around at the end of the problem. I need to round this off. How many sig figs should I round it to? Well, let's see how many sig figs the inputs have. How many sig figs does 7.20377 have? It has 6. 1.1 times 10 to the 4. That has 2 sig figs. And 1500, by our convention, it has 4 sig figs. The smallest number of sig figs is 2 on this input value, so the answer should be rounded to 2 sig figs. The answer I should put on my paper is 53. Don't truncate the number. Don't just chop off everything after the first 2 digits. You need to round up if necessary, if the next digit is a 5 or more.